Bismillahirrahmanirrahim. In this lecture, I am solving problem 3.37 from the book Thermodynamics and Engineering Approach by Cengel, 9th edition. So the statement of the problem is 1 kilogram of water vapor. So in given data mass is given to us as m is equal to 1 kilogram. At 200 water vapor at 200 kilopascal. Working fluid is water vapor at 200 kilopascal. Initial pressure is equal to 200 kilopascal. The 1.1989 cubic meter left chamber. So initial volume is of this left chamber, initial volume of this left chamber V1 is equal to 1.1989 meter cube, and if we want to find specific volume, so mass is 1 kg, it means that total volume is equal to specific volume. Specific volume is equal to total volume divided by mass. Total volume is 1.1989 meter cube and mass is 1 kg. So it means that total volume and specific volume are equal, meter cube per kg. The right chamber has twice the volume of the left and is initially evacuated. Initially this is empty and initial volume is this. Determine the pressure of the water of the partition has been removed. When the partition is removed, then final volume will be total volume, and we know that, let's suppose this is V1, so this is twice of this volume. It means that this is 2V1. This is V1, so it means that this is 2V1. So V2 is equal to V1 plus 2V1, which is equal to 3V1. It means that the total volume is 3 times of the initial volume. This is initial volume V1 and the whole space is the final volume. So this is V1 and this is twice of this left space. So this is 2V1. So V1 plus 2V1 is equal to 3V1, which is equal to 3 multiplied by 1.1989 meter cube per kg. So V2 is equal to 5.1769 meter cube per kg. This is final volume and specific volume, and we know that mass is 1 kg, so total volume and specific volume are same. Similarly, and enough heat has been transferred, temperature will be decreased, so the temperature of the water is 3 degrees. Final temperature is T2 is equal to 3 degrees centigrade, and required is to find the final pressure. Required is to find the final, here it is mentioned. Determine the pressure of the water after the partition has removed. So it means that we have to find final pressure. So we start solution. So first we draw TV diagram, temperature on the y-axis and specific volume on the x-axis, TB, meter cube per kg. This is saturation curve. So initially we know that P1 and V1 is given to us. So first we find whether it is in the wet region or in superheated region or in compressed liquid region. This is wet region or mixed region. This is superheated region and this is compressed liquid region. So from saturated steam table, at pressure is equal to 200 kilopascal, find Vf and Vg. So this is the saturated steam table, and this pressure is 200 kilopascal. So in front of this, Vf is 0.001061 and Vg is 0.88573. Vf is equal to 0.001061 meter cube per kg, and Vg is equal to 0.88573 meter cube per kg. So let's suppose this is Vf and this is Vg. This is Vg, and V given to us is greater than Vg, and V, this is Vg, this one is V, but V given to us is greater than this one. It means that the initial point is in the superheated region. As V1 is equal to, which is given to us as 1.1989 meter cube per kg is greater than Vg, more than this value. So this is in the superheated region. So point 1 is in the superheated region. So this is, let's suppose this is point 1. This is point number 1, greater than Vg, so it is in super. Now we are finding point 2. So at point 2 T2 is given to us and V2 is given. So from saturated steam table at T2 is equal to 3 degrees centigrade, find Vf and Vg. But if we check steam table, so 3 degrees centigrade is not available. So here in front 0.01 degree centigrade and 5 degree centigrade are given to us. So in front of 5 degree centigrade Vf, these are the value of Vf, and these are the value of Vg. So let we check this one. We know that V2 given to us is 5.1769 meter cube per kg, and the steam table temperature in degree centigrade and Vf in meter cube per kg and Vg in meter cube per kg. So 3 degrees centigrade is not available in steam, but in the table 0.01 and 5 is available. In front of 0.01 degree centigrade, volume Vf is 0.001000, and in front of 5 degree centigrade both are same 0. It means the volume is almost constant at these values, and Vg is 206.132, and here Vg is 147.118. Here this video 118. So if we check V2, V2 is greater than these values Vf and smaller than these values. If we interpolate at 3 degrees centigrade, so V2 will be between these two values. But it is clear, no need of interpolation, because it is clear to us that V2 is greater than these values and less than these values. It means that V2 is in saturated region, as V2 is greater than Vf values at 0.01 and 5, and less than Vg values, all these values 206 and 147. It means that here, let's suppose this is 158, let's suppose. So V2 is very small, 5.616, very small. It means that V2 is in between these two values, between VF and VG. So as V2 is greater than VF values and less than VG values, so point 2 will be in mixed region. Mixed region mean in mixed region. Mixed region is basically liquid plus vapor region. So let's suppose temperature is very low, so it means the temperature will be here something. So this is, but volume increases, so it will be here. So this line will be something like this, because volume increases. This is V1 and this is V2. V2 is greater than V1. So this is the process from 1 to 2, and we know that point 2 is in point 2 is in mixed region. So here the pressure is saturated pressure, is point 2 is in mixed region, so P2 is saturated pressure. P2 is a saturated pressure. Saturated pressure mean here this line is this is PS, and here temperature is 3 degrees centigrade. So this is saturated pressure. So we will find saturated pressure at 3 degrees centigrade. So from saturated steam table, at temperature is equal to 3 degrees centigrade. At temperature is not available, so we will do interpolation. 0.01 degree centigrade and 5 degrees centigrade are available, but we have to find pressure at 3 degrees centigrade. So in front of 0.01, pressure is 0.6113. 0.6113. Here we have to find P2 in front of 3 degrees centigrade, and in front of 5 degrees centigrade pressure is 0.8721. 0.8721. So do interpolation. So third value minus first value divided by third value minus second value is equal to third value minus first value divided by third value minus second value. So solve this and find P2, which is equal to 0.767 kilopascal. So this is the final answer, and this is the end of the problem. And for more problems, please like and subscribe my YouTube channel and share with your friends. Thank you.